Hello everyone. Today I'm going to talk about the StereoNet and question related with StereoNet. Came IIT. IIT JAM exam, GATE exam, as well as in NET. And apart from that, other exams too. The question related with this already came, and in future definitely it will come. Okay, so this topic is very important as a geologist because we can get a lot of information from StereoNet. Okay, because from the StereoNet we will get the regional picture of the area. Okay, the data that we are taken in our field or while doing field work, we have collect lot of data to plot that data, and to get output from that data is for that we use StereoNet. And that's why the question related with this comes in most frequently in the exams. And so hope you learn something from this video. Okay, so now I'm going to going in detail in this video. Okay, so first, the main thing is that what is StereoNet. Okay, StereoNet is graphical representation of lines and planes. We call it as a StereoNet. And in a simpler word, 3D view in 2D. Okay, so there are generally two types of StereoNets. Okay, first one is equal area network. We call it as a SMITS. And there is one more, call it as a stereographic net or wolf net. Okay, the main difference between these two is in equal area net. Okay, the main difference between the two is in equal area net, area preserved, but in stereographic or wolf net, angle preserved instead of area. Okay, there are two more things, that is pie diagram and beta diagram. Okay, in pie diagram we plot pole to planes. Okay, and in beta diagram we only plot plane. I will go and explain these things in detail. I will explain these things in detail, okay, while I will especially take this exercise, okay. So now in this video I'm focus mostly on the basics, okay, basic of stereo nets, okay. So now for and these two pictures represent the equal area net, okay, because we in structural geology we use the equal area net, okay, we do not use the stereo net or wolf net, okay. And how we use the stereo net, first I will show you in the 3D view, then I will explain these things, okay. Simultaneously we will go, okay. Suppose this is our sphere, okay. Suppose this is our sphere, okay. This is our northern, this is the southern pole, okay. And we call this point as a zenith point, okay, also, okay. So this is our, if I remove this, this is our northern hemisphere, this is our southern hemisphere, okay. And the most of the structural data are below the horizontal plane, okay. So suppose this is our horizontal plane, so that's why we are plotting our data in the southern hemisphere, okay, in the lower part, okay. So now suppose I will start with the planes, okay. How we will depict those things in our, suppose this is our horizontal plane, okay. I want to represent this horizontal plane into a 2D sheet, okay. So how we will represent this in 2D, okay. And another plane, that is vertical one. Suppose this is our vertical plane, okay. Then how I will represent this vertical plane into this, okay. Main thing is that, okay. So now, and there is one more plane. Suppose this is our another plane that is inclined, okay. And how I will represent this plane in this 2D, okay. So now if my plane is vertical, okay, suppose this is our plane, I want to project this plane, okay. There is one more hemisphere that I have removed, okay, and whose northern, that we call as north pole or something like that, okay. We call those point, we call that point as a zenith point, okay. We call that point as a zenith point, okay. I will connect these points, these plane points, okay, these plane points with this zenith point that is lying above, okay. Okay, so I will connect these points with this zenith point that is lying above, okay. So the points, these line, these planes, okay, will cut this horizontal sheet, okay. We'll getting this horizontal sheet now. Let's cut it. Okay, we are getting an imaginary point on that. Okay, so if our plane is vertical, okay, we will get a straight line that is passing from the center. If our plane is vertical and if we want to connect these points with the zenith point, we will get a straight line, okay, that is passed from the center, and its dip amount is 90 degree. So it means our this center represent our 90 degree, 90, and this is our 90. This is our horizontal, means 0. It means this circular equatorial circle will represent our horizontal sheet. Okay, we'll use some other color so that we call it as a primitive circle. Okay, PRIMI, primitive circle. Okay, we'll use some other color. Primitive circle. Okay, and it is equal to horizontal plane. Okay, and that vertical, this one is our vertical plane that will pass from a center. Okay, with and these north south connecting lines, which we call as a okay, we call it as a great circle. Okay, and here we are getting 0. This yellow line is representing 0 degree. Okay, and the middle one is representing our 90 degree. Okay, and if it is tilted with some angle, suppose 30 degree, suppose this is 30 degree. Okay, now connect this point with the zenith point. It will cut these horizontal sheets. It will cut this horizontal sheet. Okay, so suppose this plane is dipping with 30 degree. Okay, we will start from here, 0, 10, 20, 30. This is our great circle. I will tell you. Okay, we call it as a great circle, which we also called as longitudinal lines. Great circle, longitudinal lines. Okay, we call it as a great circle. And why we use great circle? We use great circle for plane data. Okay, and this is representing our inclined plane. Plane dipping with 30 degree towards east. And if I talk about this, this is vertical plane. Okay, 90 degree. Trend is north south. This inclined plane is also trending north south. Okay, and this yellow line already mentioned. Okay, already mentioned. We call it as a primitive circle. Primitive circle is equal to horizontal plane. Okay, and this small circle, great circles are in north south, and these small circle are in east west parallel to equator. Okay, we use this small circle for amount, like line amount, rake, pitch. In that case, we will measure our data from here. Start here, from here, okay, 0. Center is 90, okay. If you look at here, 90, 0 to 90, okay, 0 to 90, okay, 0 to 90, okay, in this way. How we'll use, I will tell you, okay. So to this, hope you understand. Okay, this is our east, this is our west, this is our north, this is our south. Okay, and this line, this is our small circle. Okay, we call it as a small circle, and this small circle will represent the, I have written here line data will be represented by small circle. Okay, for calculating this. And if we want to calculate the plane, then we will use east-west line, and if we plot our line data amount, we will use north-south line. Okay, in this way we will plot these things. Okay, how to plot I will explain. Okay, and what kind of data we are plotting in this StUnit. We plot strike and depot plane. We plot bedding, fall data, joints, fractures, foliation, all the data that we are collecting, mineralization data, rake, pitch, everything we will plot. Okay. Apart from that, there are many more data that we can plot in the StUnit. Okay, and the StUnits are very important to understand the things. Okay, so now I will show you something. Okay, how I can imagine these lines, these things. Okay, suppose this is my inclined plane. Okay, how I can imagine it on a horizontal sheet. Okay, suppose this is my plane. Okay, it is dipping like this now. Roughly I am drawing. Okay, it is like this. Now this is our zenith point, ZENITH. Okay, zenith point. Okay, now I will connect these imaginary lines with this. I will draw some imaginary lines. Okay, it will cut this. It will cut this equatorial plane somewhere, like here, here, here. We will connect those points. Okay, now I'm able to see this thing. that where we see on this. Suppose this is 30 degree, so here it is 30 degree. So in this way we are imagine. Okay, in this we are seeing the 3D, and we are now able to see the 3D view in two dimension. Okay, so this is the way. Okay, hope you understand something from this video, and try to share this video with your friends so that they can also get the benefits. And if you have any doubt or still can't understand, just mention in the comment box. I will try to modify this video, and the things that are ununderstandable, not understandable for you, you just mention in the comment box. Thank you. Hope this video will be helpful for you peoples, and related exercise I will upload it soon. Thank you.